Okay, sorry, it stopped recording in the middle of the last video, but I was here. I'm using Maple. It does everything your graphing calculator can do. What I did is I just put in what we got for the derivative here, right? That's 5x to the fourth plus 20x cubed minus 3x squared minus 36x plus 18. Yeah, that's what we got for the derivative. And what we said was we wanted to find the critical numbers, which is where the derivative is zero. Well, the critical numbers is where the derivative is zero or undefined, but we decided it's never undefined. So what I'm going to do is I'm just going to look at a graph to determine where the derivative is zero. So this is how I tell Maple to draw a graph. So you know how to do that in your graphing calculator. And it produces this graph, which I can look at the graph to kind of guess where it's zero. So it seems to cross zero here at maybe -3.5 and at about -2. And then if I look closely here, it looks like it crosses twice. It goes just below the x-axis and then it goes up again. One thing I could do to try to really find these off of a graph is, for example, I suspect I have something right around -3.5. So what I can do is try to zoom in a little bit. Why don't I graph it from -3.6 to -3.4. Yeah, then it looks. Then I can like zoom in. So it looks pretty confident that there's one at -3.5. And then, right, I can zoom back out if I like. And then find the next one. It looks like the next one is like -2 or so. So you can find these things just by looking at the graph if you choose the right window and try to zoom in and keep in mind that the problem says to round everything to do 2 decimal places. You can find it off of the graph. You can also, if you know how to use your graphing calculator to do this, you can have the graphing calculator just tell you the approximate solutions. So on Maple, I do this by saying fsolve. And that tells me these numbers. And sure enough, the first one is extremely close to -3.5. That's about what we were expecting. Here's one that's very close to -2, and that's the answer that we were seeing right around here. And then there's these two numbers. There's about 0.6 and about 0.8, and that would be the 2 points where it crosses here, because it looks like it goes just barely below the x-axis, and then it goes back up. So that would be these 2 points. Right, so those are the points that I want to mark, and I'm rounding everything to 2 decimal places. So 3.499 would still get rounded to 3.5, -3.5. And then there's -1.96. And then there's 0.62. And then there's 0.84. And remember, what I want to do is this breaks the real number line into 1, 2, 3, 4, 5 pieces. There's 5 intervals, and I want to say whether the function is increasing or decreasing on each one, which just means whether the derivative is positive or negative on each one. In the past, the way we've done this is I've chose a number in between, like I chose a number in this interval and plugged it in to see whether the derivative was positive or negative. Since we are using computers and calculators to do this, I can just look at the graph of the derivative. Once again, this is the graph of f prime of x. And I can see that it is above the x-axis here. So to the left of this negative 3.5, this is positive. So positive goes here. Then in between here and here, this number that's about negative 3.5 and this number that's about negative 2, we go below the x-axis. So that's negative down here. So negative, and then, yeah, I'm not going to keep going back and forth from the screen to the paper, but you see what I'm doing. In between here and here, it goes positive, and then negative, and then positive again. Keep in mind that this negative is because it barely goes below the x-axis right here. We can barely see it going below, so it is negative in between those two. Yeah, so in conclusion, we can just say intervals of increase, negative infinity to negative 3.5, that's one. And I'm just going where all the pluses are. Negative 1.96 to 0.62, and 0.84 to infinity. That's where it's increasing. Intervals of decrease, that's where I have a minus, so negative 3.5 to negative 1.96, and this one, okay, so that's part of my answer right here. The rest of what I have to do is I have to do the same thing but for concavity. So this is going to be repeating the same steps with the second derivative, and then I need to identify any inflection points. But by the time I'm done with concavity, I'll basically be done with the inflection points. Right, so the second derivative is f double prime, which would be, okay, we found f prime up here, so I'm just doing the derivative of that. 20x cubed plus 60x squared minus 6x minus 36, like that. Now I want to make a number line. On my number line, I want to mark any numbers where the second derivative is 0 or undefined. This is never undefined. This is a polynomial. But I should still find where it's 0. I can do my same tricks to determine that. So here I put in the second derivative, 20x cubed plus 60x squared minus 6x minus 36. And I plotted that. And then again, I can do the same trick. I can see the numbers where it's about 0. One way of finding this exact number, well, I shouldn't say exact, but finding it more exactly, being able to estimate it to 2 decimal places. One way of doing it is to just zoom in and to like plot this graph on a different window where I can see what's going on here more closely. And then I would also want to zoom in around here and also around here. That's one way to do it. Another way to do it is to do what I did before. Solve g of x. And that tells me negative 2.888, and that looks about right. That looks like it's about this number. Negative 0.84, that looks like it's about this number, and 0.73, that looks like it's about this number. Okay, so those are my numbers. There's negative 2.888, so I would round that to 89. And then this one would get rounded to negative 0.85, and then this would get rounded to 74. But in any case, I mark those numbers, and then again, this breaks it into some intervals, and I would like to fill in a plus or minus in each one. Since I'm already looking at the graph, this is easy, so it goes negative, positive, negative, positive. Negative, positive, negative, positive. And this tells you concave up or concave down. Plus is up, minus is down. So intervals where concave up, that's this one and this one. Intervals where concave down, that's this one and this one. Okay, so now we did almost everything. We found the intervals where it's increasing, decreasing, concave up, concave down. Lastly, let's find the inflection points. An inflection point is where the concavity changes. I am well positioned to determine those by looking at this number line. Concavity changing means it's changing from a plus to a minus or a minus to a plus. Sometimes when you do these number lines, you'll see one of these numbers and maybe it has plus on both sides or minus on both sides. That's not an inflection point. An inflection point is where it changes. So for us right now, we have a few changes. In fact, there would be one here, here, and here. So I see 3 inflection points. And I can tell you their x coordinates right away. These are the x coordinates of the inflection points. To get the y coordinate, I have to plug in that x coordinate. Now, be careful here. You want to plug it in the right place. The inflection point is supposed to be a point on the graph, on the original graph, the original graph of this function. So what I'm going to do is I'm going to plug the values of x into this function. I'm not plugging these values of x into the first derivative or the second derivative or anything like that. The original function. That tells me what this y coordinate should be. But I am just gonna use the computer to do that. So, sorry, this will take just a second. X to the 4th minus x cubed minus 18x squared plus 18x. I'm just entering the original function into Maple. And then what is f of negative 2.89? I get, yeah, so I'll show you the screen. So yeah, I just typed in the function and then I asked what is f of negative 2.89, and it told me that. negative 31.03. And I'm just going to go ahead and do that for these other two. So f of negative 0.85 is whatever it is, and Maple is telling me that's negative 25.52. And then whatever this one is, .78, and those are the inflection points. So that's it. We did everything. Once again, keep in mind the instructions here were to round it to 2 decimal places. If we were told not to round, we would want exact numbers for all of these. And I discussed what that means.